Hi, today we're going over the build of an Eggtimer voice module. The voice module is an add-on component for the Eggtimer LCD receiver, which can be used in two configurations, either GPS mode or telemetry mode. And the Eggtimer voice module can be used for both of those configurations. In the GPS mode, it will read out your GPS location or your direction and azimuth while you're in navigation mode. And in the telemetry mode, it will read out your telemetry data during the flight, and which data it reads out depends on the flight computer that you're using. This is my setup. I use a Hakko FM203 soldering station. It's a fairly expensive station. You definitely don't need anything this elaborate, but it does work very, very well. I use a 3mm soldering tip usually for these kinds of builds. I do have a silicone mat, which I enjoy using a lot. It's great for your workstation. I use a pan device, which we'll show later. And I do have my own roll of Kester 0.02 inch soldering wire. It's the same stuff Eggtimer sends out. If you don't have something like that, definitely use the solder that comes in the package. So this is the package that you get from Eggtimer. It's a white blister pack, just like all of the other components they send out. Open it up, and we're going to inventory everything first. So take everything out of the package and lay it out on your workstation. I do highly recommend that you don't skip this step. Don't skip the inventory step. It's quite important, I think, especially in this kind of board where you only build like one of them, maybe two of them. You're not building a lot of these like you would, say, flight computers. So it's definitely beneficial to do an inventory, not just to make sure that you have all the parts, which is important. But honestly, I've never actually had a package from Eggtimer that didn't include all the parts. But this also gives you an opportunity to identify each part and lay it out neatly, so that when you're actually going to do solder the board, it's a lot easier, and there's no chaos, and there's no misidentification of parts. So lay everything out on your workspace, get the checklist out, and mark off each component as you identify them in the inventory. We're going to be doing the Rev A6 version of this board that was current as of the end of 2022 when I'm building this. If Chris comes out with another version, I will do another video. But for now, we're doing the Rev A6 version of the voice module. So the first component on the list is the PCB itself, and that's what you're going to solder all of the components to. So put that to the side. The next component up is the Atmel 28-pin processor. Hard to miss. You can't miss this one up. It's a big, rather large chip, and it's the biggest component besides the PCB in the package. So you should be able to identify this easily. Next up, you've got the 2.2 ohm resistors marked 2R2. This is a white paper carrier. This is what Chris means when he says that, and that's really important when we talk about the capacitors, because all of the resistors will come in the white paper carriers. Next up, you've got some 10K resistors. These are marked 103. Now for both these, you get one extra in the resistors, and that's really important in case you drop one on the floor, because they're tough to find. This is a wired resistor that you're only going to need if you decide to mount the headphone jack to the board itself. These are the capacitors. These brown capacitors all look pretty much the same, but that's, again, the white paper carrier. And in this case, the 0.1 UF ones, you do get two of them, and you're only going to need one. But these next ones, this red stripe one in a plastic carrier is a 22 UF, and the next one in the blue is a 47 UF. Each one of these you only get two, and you're going to need two each. So be real careful with these, because once again, you drop one on the floor, hard to find. So don't be careful when you open up those packages. Next up is a ceramic 16 megahertz resonator. It's a blue part with 3 leads, or the one I got in my package was blue, and it looks like this. Put that to a side. Next up, you've got the jumper cable. It's got a 3-pin connector on each end. We're going to modify that later, and that's for connecting it to the LCD board. You get a 3.5 millimeter stereo jack that you can use to connect your device to that you're going to use for audio. You get a piece of 3-pin angle header. I'm going to add an angle header as well, a 2-pin later on. You'll see where we put those on the board. You get a piece of heat shrink tubing that you can use to put at the end of the jumper cable wires to coat them. We're going to do also something a little bit different there. I've got some connectors that I'm going to use, but that's one thing you could do to use the heat shrink tubing. And then finally, you get a piece of soldering wire from Chris that is excellent solder wire. I do recommend you use it if you don't have your own. I do have my own, same exact stuff in a spool, so you won't see me use that stuff out of the package, but it's very, very good soldering wire. I do like to set up my board. It really helps to make the flow of the whole process easier. When everything's all in chaos, it's tough, but when it's all nice and neat, it's easy. I use this pan device, as I noted, awesome piece of equipment. I use it for so many things in the hobby and other things. Really recommend getting one of these. It makes it easy to move the board around. I use 2 pairs of tweezers, a pointy pair and a flat pair, which also make things a lot easier if you have both on hand. So the first component up to solder into the board is the large Atmel chip, the 28-pin chip, and you need to make sure you orient it correctly. That little notch needs to line up with the silkscreen notch on the PCB. If you don't get that right, the board will not work. You'll probably ruin something as well. And you'll probably have to gently kind of press the pins together. Try to put, equally, press them in equally on both sides so the board sits flat. And you don't want to be really harsh here. Just lightly squeeze them together until you can get it to fit. Move the board around until they fit in the holes. Once everything's correctly oriented and you get the chip in there correctly, it should be nice and flat, but not all the way to the board. You want a little bit of a gap there. Don't try to shove it all the way down. And then I like to, as the instructions note, solder the opposite pins, and then it kind of holds the board in place, but also it gives you a chance to check, make sure you've done everything correctly, everything's lined up properly, it's still seated properly, and that notch is in the right place. So actually turn the board over, take a look, make sure everything looks good. If you're comfortable and everything is oriented properly, then go ahead and solder in all the pins. I'm going to speed things up here so that you don't have to watch real-time pin soldering, but go ahead and make sure that each one is properly seated. You get a good cone of solder, and that it's seated. The solder is seated into that hole very well. Once that chip is soldered in, the next thing up is one of the 0.1 UF capacitors. And these are all going to be very similar with the others as we go through this, the surface mounted parts. Just basically tin 1 pad, a little bit of solder. Take your tweezers, move the component into place to kind of tack it into that pad, and then let it cool for a second once it's lined up. And then you can solder it in place securely. And you should have a nice little tent of solder on each side, and some of the solder should get underneath the chip on the pad, but not all the way to the point where it's bridging to the other pad. And it should be a nice shiny tent, which would indicate you do not have a cold solder. So once that one's in place, the next one up is the 103 chip in the proper spot there, and it's the same mechanism. And I will keep this one at kind of normal speed so you can see it one more time. And also, you might notice that I'm kind of having a very long piece of solder. It's because the camera, if I get my fingers too close into the picture, it focuses on my fingers or the soldering iron. So I'm trying to hold it very far away. I don't normally hold it that far away. It's hard to control the solder wire, but that's the only reason I'm doing it that way. Also, you'll notice I'm flipping the board around a lot with the pan device. That's one of the benefits here, and you can always put it in the orientation you want. Next up is going to be a set of these capacitors and then resistors. So really make sure you get them in the right spot. I'm going to speed up the video here so you don't have to keep watching the surface mounted installations over and over again in real time. But do make sure you've got the correct component here, because especially these capacitors, they look very similar, and it's really easy to mix them up. So make sure you've got the correct capacitors in the correct spots. In this particular case, we're putting the 47 UF ones in the blue package in first on the bottom, and then the next thing up will be these 2.2 ohm resistors, Mark II R2, into their particular spots. And all of these are put in the same way. It's just that the capacitors look very similar. And you can see there, these can get very slippery. Especially these small 2.2 ohm ones were a little bit smaller actually, and so kind of hard to get a hold of. But make sure they're lined up properly, and just reheat the pad, stick it in place, and then solder them securely. And just to reiterate one more time, be very careful with these particular capacitors, the red ones and the blue ones, packaging, because there's only two, the exact number you need. So if you drop one, you probably have to call Chris and have him send you one. Once these are all in place on the back, we have finished all of the components. I'm sorry, on the front of the board, we've finished all the components, surface mounted components. So pretty quick build here. Next thing up is the resonator. And you will have to bend these the pins on this component 90 degrees. Now, I'm sure there's going to be some electrical engineers who watch this, and I am not an electrical engineer. I'm just a hobbyist. So, someone's going to look at this and say, "Wow, that's the horrible way to do this." But it seems to work for me. You just take a pair of tweezers, bend them approximately the right spot. Make sure they're about not quite 90 degrees, because you want to be the chip kind of rockers on that round resonator. So make sure you got the bend just a little bit less than 90 degrees, in my opinion, to get it to sit right. And then likewise, when you tape it flat like this, it's trying to pull it out of the hole. So I take another piece of tape and kind of do it lengthwise and pull it into the hole, so it's all the way, so the pins are all the way through. Once you're comfortable that it's seated flat and the pins are all the way through, solder the 3 pins on the back securely, as normal. Just make sure you get a good tent, and you get solder seated in those holes properly, and that'll hold that resonator in and connect it. Next up, we're going to have to make some decisions about the 3.5 millimeter headphone jack here. If you do decide to connect it to the board directly, you need to solder it in and then put one of these wires through the flange there down into that hole marked C. We're not going to do it because I'm going to be putting this into a different case. But if you did do it this way, you should solder the outside of the 2 pins on the headphone jack, and then solder the resistor wire to the flange. This is the case I'm going to use. It's a black arrow case. You can see I've mounted the 3.5 millimeter jack on the cover. There isn't a lot of room to mount it anywhere else, so it's where I found it to be the best. So in order to do that, I want to be able to disconnect it and disconnect the cover. So I'm using some micro JST jacks, and in order to get all of this connected properly, I'm using an extra angle header, a 2-pin angle header that I had on hand, and mine are a little smaller, and they sit almost flat to the board, so I bend them out just about 45 degrees, give or take, so that they're pointed up and not sitting right where we're going to try to solder the wires for the 3.5 millimeter jack. Now here's the end of the wires. I cut off the wires for the JST micro connector, and I'm just going to put them in order. the yellow wire goes to this. I'm putting it on the C hole, the hole marked C on the board, and that's what's going to get connected to that little outside flange on the 3.5 millimeter jack. And I'm holding the wires in place with a helping hands alligator clip, kind of recommended. You can kind of pull the wire through the hole using a pair of tweezers and then connect your helping hands to it. It's really useful. But the red wire is going to the R, or the right hole for the headphone jack, and then the black wire will go into the left hole. So once you have, in this case I'm using the micro JST connectors, but once you have whatever cable you're going to use connected, it should look something like this. And then I just like to flatten those wires against the board, because we are going to have to put those angle headers on, so you want some room. Make sure everything's nice and neat and clean. And this is what it should look like. So once you've got that in, the next thing up is these angle headers. In order to get the angle headers taped in right, I like to just put the pins right through the tape and then tape it to the board. If you try to kind of put it over the pins, it just makes it all try to lean over. But if you put the pins right through the tape, you can securely put the angle header right to the board and then just trim your tape off on the other side and solder your pins in as normal. And use a pretty decent amount of solder here, because it's you're going to be pulling cables on and off that headphone, that angle header, and it kind of wants to rip it off the board. So do the same thing. I'm using, once again, you don't have to do this angle header here. You can just solder cables straight to the board, but I'd like to be able to connect and disconnect cables, so I'm going to use a 2-pin angle header here that I had on hand. This did not come with the kit, but solder those in. And then once we have that done, we have completed all of the soldering we're going to do on the PCB. And the next thing we need to do, though, is connect cables to the headphone jack. So they're going to be short. I need the cable to be shorter inside the cover of the case. So I cut the red and black wires out a little bit short, and then cut a piece of heat shrink tubing to length, so that you can make sure you cover that connection over the flange of the headphone jack. So in this case, cut one for the red wire and one for the black wire, and don't forget to put it on the wire before you solder it. I've made that mistake many times, and then had to cut the wire off and resolder because you forgot the heat shrink tubing. So don't forget that piece. In this right now, I'm connecting the red wire to the lower flange, and then I'm going to connect the black wire to the upper flange. I'm not really sure it matters one way or the other, right or left, in this application. And then you'll notice I left the yellow wire long. It's because it's going to get connected to that side flange, and it's a little bit longer, obviously, than the two bottom ones. So once you've soldered those in, cut your yellow wire to length, so you have just enough to solder it on. Leave yourself just a little bit of room. So cut the yellow wire, strip the end, and then solder that onto that side flange. Once again, don't forget to put the heat shrink tubing on. And then once that's soldered in, go ahead and once it's cool, slide up your heat shrink tubing all the way up as far as you can over that flange to protect the connection. Make sure nothing shorts it out. I use and this is what it should look like. The heat gun I use is a Weller heat gun, specifically designed for wiring small components. It's an excellent tool. I do recommend getting it if you can afford it. They're kind of expensive, but you could use anything, hairdryer here or a regular heat gun, whatever you use to do your heat shrink tubing. But this particular tool just it gives you almost the exact perfect temperature, and it's a very directed flow of air. So it is a really excellent tool. Once you have all of your heat shrink tubing shrunk onto the connections, you will be pretty much done with this 3.5 millimeter jack. And we won't mount it now. That's going to be in a different video. Mounting the whole thing and connecting it to the LCD in the case will be. But what we will do is test the entire apparatus right now, make sure the module works properly. So in order to do that, we have to be able to connect it to the LCD board. And in the instructions, it talks about connecting one of these 3-pin DuPont connectors from the end of the cable and then using heat shrink tubing over the end. I like to disconnect the 3-pin connector and put single connector DuPont connectors on the end of each cable. It's my preference. I just feel like it's a little bit more secure, I guess, better. The heat shrink tubing works just as well. But if you do have some of these DuPont connectors, you can put them on the end. They're very easy. I'll put a link in the description below. For very little amount of money, they're so cheap. And you use them on so many of these builds that it's really doesn't seem like a big deal to just get them, because they come in a package of like 500. I'll never use them in my entire life for like $10 or so. At just a few cents a piece, you can get some. But once you have those put in place, it makes it very simple. You're going to connect the 3 individual cables to the board, to the voice module. The white cable goes to the aux pin on the voice module. The red one goes to the 5-volt connector that we use that 2-pin header for, and then the black cable goes to the ground connector on the board. If you have a newer LCD board, there is already an aux connector there. Just make sure that the proper pins are lined up, and that's where you would connect it to. And then connect a audio device and a battery, and if we connect these properly and we did everything, then it should be a first time go.
Power on.
And there we go. We had a first time go. That's excellent. And that's the way it should look and sound if you did everything properly. So that's it. That's the voice module for the from Eggtimer for the LCD board. If you have any questions, post it below. But other than that, good luck, and I hope it works for you.